see if I started the recording. Let's see if it's started. Okay, so the recording has started. All right, guys, so welcome to Thursday, March 9th, Computer Science, Computer Engineering 102. So we're going to be talking about today. So last time we finished our discussion on object-oriented programming in general. Now we're going to talk a little bit more about how to specifically kind of think in objects. So to that end, today's quote is actually kind of about thinking differently. Right? So Grace Hopper, who I wish that I could say my daughter is named after, but she's not. But she was the inventor of the first compiler, and she tells us that if one ox could not do the job, they did not try to grow a bigger ox, but used two oxen, so two animals. When we need greater computer power, the answer is not to get just a bigger computer, not to get bigger and bigger and bigger, but to build systems of computers and operate them in parallel. So this has to do with parallel processing, multi-core processors, these kinds of things that are very common today, but actually a long time ago they weren't, right? It wasn't necessarily how they used to think. They used to think, if we want to make things run faster, let's increase the memory, let's increase the data storage, stuff like that. But once someone said, well, what if we had two processors working together? So in the same way, the answer to what we're going to be working on isn't going to be necessarily just try to write better sequential code, but instead we're going to start talking about how to write object-oriented code. Okay, so all right, so again, we talked about advantages of object-oriented programming from the previous chapter. The chapter, the chapter 10 that we're on now, will talk about how to solve problems using object-oriented programming. All right. Okay. So let's talk a little bit. Let's get out of this. Actually, I don't want to. This is kind of some of the stuff you can kind of read on your own. Okay. But the idea is that there are certain things that we want to have inside of the class that is going to define things for all the objects that will be of that class type. Okay. The specifics of how that is done inside of the code is going to be hidden from the user. Right, so like the method, what actually the code in the method is going to be hidden from the user, but they will have access to the method names that are part of it. So, for example, in the string class, that you guys have used strings before, things like the length method, or things like all the different other methods like replace, two lowercase, two uppercase, all of those things, you don't know what's inside of the code in there. I don't know what's inside of the code in there. I just know that method exists and I know what it does, right? So as we start designing our classes, we will be able to say, these are some methods you can use for our class, and these are what those methods do. But we don't necessarily have to tell the user how it's done, okay? All right, an example they talk about has to do with the loan class, which are things where it's a bank loan example where you have things like interest rate, number of years until payoff, how much was the original principal amount, when did it start on, things like that. These are all things that, these are all methods that we implement in there. Notice that all of the attributes here are private. Remember the minus sign, we talked about that last time yesterday. The minus sign means it's a private attribute, meaning that we know that that attribute is in that class, but we can't get directly to it. So if we create a loan object, we can't do loan dot annual interest rate, right? And get direct access to that variable. In order to get the value of that, we have to use the get annual interest rate method instead. Okay, notice also any get methods are going to have the same type as the attribute they're associated with. Any set methods will take that attribute type and return void. Okay. So a couple of different things that you notice. Also, get monthly payment. There's no attribute called monthly payment. The reason for that, this is a calculated value. It's based on the loan amount, the number of years remaining, the interest rate. It uses all of that to calculate how much someone's monthly payment is. I don't know, many of you are probably too young to have had a loan in your life, or a large loan, other than maybe like borrowing money from your parents or from a friend or something. But I don't know if many of you have experienced getting a loan from a bank, but that is one of the things that a bank or a credit card will do, is you'll have a loan amount, then you'll have an interest rate, and then basically you don't just pay back the original loan amount, do you? No, you have to pay back the loan amount plus the interest that accrues over the time that is that the loan continues on for. It's quite an interesting thing if you ever have some time to look up. Let's say you had a loan for just even some value like 1,000 Turkish lira, or maybe like even $500 or something, some large amount, but not, not like a house. All right. But if you had a loan for, say, $5,000 at an interest rate of 12% per year, how much, if you paid it off over 3-4 years time, how much would you end up paying back completely? It's an interesting exercise to find out how much you end up paying back for a $5,000 loan. Anyway, so this is a class that we can use where, notice that again, all of our methods, we're going to make them public. We're going to make our attributes private. We'll have get and set methods for each of those. Okay. Moving on, let's see. So how, this is another example here of how to design a class, right? Now, this one, we don't have, they didn't list the get and set methods, right? They are provided, but they're omitted generally for brevity. What that means is brevity, for making it not too big, because if for every attribute that we have, we need to have a get and a set method down here, that could make a really long, tall class diagram, right? If we assume, however, that any attributes we have in here, we have get and set methods defined, then we can leave them out of this section and just assume that they are there. Okay, so BMI is another example. If you know what BMI stands for, it's body mass index. It is a value related to health. It's essentially your weight. It's based on your weight, I guess age too, but let's see, it's your weight, your height. Can't remember if age is a factor or not. I'm not a doctor, so